Hello everyone. We'll start this meeting at 6:35. So we'll wait for another 5 minutes. Okay. Okay, so I believe most of the people are here. So we'll officially start this. So my name is Oomang Bishnoi, and I'm the senior course developer for mechatronics, working for the ETG, Elite Techno Group. So what our company is doing is our company is upskilling the students, engineering students, to take this. There's a gap that that we have between the college students and the company skills that they are asking for. And let's say that you're a student of some kind of engineering, but you don't have that exposure, industrial exposure. So we are clearing that gap, right? So, so we today this meeting is about the robotics part. So before that, I would really like to welcome Mr. Mohammad Farhan Saeed, Training Placement Officer of Zakir Hussain College of Engineering and Technology. And I'm really happy to announce our association for this bootcamp. And on the behalf of the ETC, I happily welcome you on board, sir. And we appreciate mentors like you who take initiative in guiding students to become industry ready. And we also have students joining from Zakir Hussain College of Engineering and Technology. So I welcome you all, and let's get on with our presentation, right? Also, before we start, if you have any question, just write it in the chat box. We'll discuss it after the session. Or if you have a major concern regarding that topic, you can just unmute yourself and ask a question in between. Okay, so we'll make this a collaborative session, and I'll be requiring your responses from time to time, and we'll build this collaborative presentation, and let's start. Okay, so is my screen visible to you all?
Yes, sir.
Okay, good. Okay, so our presentation is about Episcore taking over building industry. So this, this presentation is all about if, we took a bootcamp few weeks back regarding the basics of industrial robotics and how many robots are there. So we'll be first discussing that, and then we'll see that what this Episcore company is doing and how this company is taking over the building industry. Okay, so getting an idea, when I say a robot, so what comes to your mind? Okay, if you know anything about the robots, just let me know. Like when I say robotics, that, let's say that robotics is taking over building industry. So what kind of robot do you have in mind? Is it the Chitti robot that you saw in the Rajnikant movie, or is it something else that you have in mind? Please speak up if you have anything.
Yes, sir.
So yeah, I mean, what robot comes in your mind when I say robotics? Okay, so we'll just I'll tell you about this. So robotics is all about automation. Okay, so if you do a task repeatedly, let's say that I'm taking this piece of box. There's a box. There's a pen. Let's say this pen. Okay, so I'm taking this up and I'm placing it over here. Okay, so I do this task repeatedly, and let's say there's a human in between, and this human is taking this pen from here to there, like several times of the day, and this is a process. Okay, so now this labor goes through some fatigue. Okay, so fatigue is like he gets tired or he gets unwell, he has to eat food, and we need to keep this. We have to complete. The company is aiming to complete the task at some specified time. Let's say that this person has to pick this place and place it here 100 times a day. Let's say there's a 8-hour shift, and he has to divide his task according to that, but he has to take break, and there is production loss in between. So so that is why automation comes into place, so that this task can be repeatedly be done without any fatigue, or with the help of robotics. The task can be achieved if, let's say that this this person takes 10 minutes to take this piece and place it over here. So this robot can do it within 1 to 2 minutes, right? So that is what robotics. But robotics is not just human. There are several kind of robotics. There are SCARA robots. There are manipulators. There are humanoid robots. Is there a question? Okay, so let's say there are SCARA robot. Okay, there are manipulators. There are cobots. Okay, so we'll discuss these all. Okay, cobots. Then there are humanoid robots. So these are a few basic types of robots. Then there are hybrid robots as well. Okay, which are taking over now. So let's start talk about SCARA robot first. Okay, so SCARA robots are just pick and place robots. So let's say this is a robot, and there are few small components. Let's say your mobile phone. So your mobile phone is made up of thousands of hundreds of chips, right? And these are so tiny chips that that is made from MSME. Like these are MSME micro mechanisms. Okay, so these chips has to be taken up and place it at a very specific accuracy. Like you have to be 99.9% accurate to be able to function this phone properly. Okay, so what this? Yes, yes, please. Okay, so what this robot does is it just takes it over here, picks it up and place it over here. So this is just the basic task of the SCARA robot. But manipulators are like this. Okay, I'll draw it here. Okay, so these are manipulators and these are links and these are joints. Okay, these are joints and links. So what this manipulator does is they have an end effector at the end. Okay, so it's some kind of a gripper. So this gripper can go to various places and can pick and place an object from somewhere and place it somewhere. So pick and place is not just the only application that a robot can do. It can do many it has many applications, like you can weld something. Like in the automotive industry, welding is done using this robot. So MIG welding, and then there's a TIG welding, and then there's spot welding. So these are the welding that can be done using these robots. Then there's also sorting and automation. Then there's many kind of other function. Okay. Then comes the cobots. Okay, so just take this manipulator for example. Okay, so Universal Robotics is a company that is taking over cobots in current environment. So let's say this manipulator, we have a teach pendant. Okay, so this is a teach pendant. Okay, this is some kind of a screen that is a teach pendant, and we can program it like when we play PS4 or Xbox. So it is just kind of a remote, and we can place some kind of exams, some kind of codes, and the programming can be done. But with the help of cobots, I can just hold this manipulator, can take it here, and just save this command. So I don't have to program it. I don't have to go to the hassle of learning the programming and then saving it. So this can be done using the hands. Then there's humanoids robot. So humanoid robot is kind of a human, like it will look like me, and this will perform various tasks like giving you, like serving you, and then cooking, and talking to you, and these kinds of tasks are performed by humanoid robots. Then hybrid robot. So what is a hybrid robot? So these robots that I'm talking about, the SCARA manipulators, the cobots. So these are all static robot. Okay, so static is it is placed in some place and it cannot move in the environment. Humanoids can move in an environment, and these are dynamic robots. Okay, so dynamic robots. So humanoid robots are dynamic, and hybrid robots are dynamic robots as well. So what these hybrid robots do is, let's take for example this humanoid robot. Okay, if we have it can perform welding, but it is a static. So to make it collaborative, we can place some kind of tire, install some kind of tire, and it can move around in the environment. And if a place requires 3 or 4 robots, this task can be done with a single robot moving around in the environment. Okay. So this is the basic idea of robot. What are the kind of robots, and how these robots can perform various tasks. Okay. So I hope that's clear. Is there any doubt? Please speak up if there's any doubt. Okay. Right. So getting on with our topic, Episcore taking over building industry. Okay. So what we'll learn in this slide. Okay. So we'll be talking about the traditional 3D printing machine disadvantage, that what is the disadvantage of using these kind of machine, and why robotics was implemented in the 3D printing, and what all changes were done, right? We'll be talking about the world's first 3D printing robot and how it set a Guinness World Record by making a house within 24 hours. Okay. Then we are going to talk about the advantages of using the 3D printing robot, and how it is implemented. Okay. Then we are going to talk about the components which are used in the 3D printing robot, and how it is made by combining different kind of equipments. Okay. So first, the question that comes to our mind is it really possible to print a building? I will require your answer that what all do you think would be the problem of printing a building? Please speak up. Like what all comes to your mind that can it be done, or why cannot it be done?
The 3D printing.
Sorry,
can
please speak again.
So you are talking about 3D printing, right?
Yeah, I mean, I'm talking about. Do you think that it can be done, or if not, what is the reason? If yes, then what is the reason? What do you think?
So I think it's possible to print anything, literally anything in a 3D printer.
But like, let's say that you live in a house. Okay, so you live in a house and you have a big room. So by 3D printing, I'll have to pick this tons of rock from somewhere and place it somewhere. So is it possible, or do we have some better option?
Yes, we do, sir. Like in the 3D printing, the material we use is extremely light, so we can, and it's durable too.
Right. Actually, so what this company did is, so traditionally, what the thing was done is that we used to print some kind of bricks. Okay, so that brick was picked up from the factory, from the manufacturer, and it was placed in the place where it was to be installed, and that is how traditionally the 3D printing was done. Okay, but this Episcore did a different thing, which we'll be talking about in the coming slides. Okay, so this was the first question, that is it really possible? So yes, we have come to a conclusion that it is really possible. But the second question that should come to your mind is, shouldn't it be expensive? That we are buying bricks and cements and using the traditional method, then why such a sudden change of methods? What do you think is your opinion, that will it be expensive, or will it be cheap?
Sir, for in present scenario, it is expensive than our traditional making building form. But upcoming, I hope so it will be.
See, cheap. that is the misconception. I'll tell you why. So the thing is that manufacturing or building industry is really unexplored. Okay, so advancements was done, and what this company does is it uses fly ash with mixture of some kind of iron production. Okay, and these are then mixed together, and some kind of geopolymer concrete is made, which is a substitute for bricks, traditional bricks or cements, and manufacturing and building can be made at a much cheaper cost. You can at least save 30% by using this kind of method. Okay, so we'll break this dilemma in the coming slides. So coming to the next, so 3D CP. So what is 3D CPs? 3D CP is the 3D concrete printing, which is done nowadays using the 3D printing robot. And what are the advantages of using it? So additive manufacturing has a great advantage. So let's say that when you place a brick, okay, so brick has to be removed. Let's say that you have placed some, I'll draw it out. So this is a brick, this is a brick, and then you have one brick over other, and then this and this. So let's say that so let's say that you have to remove this brick. So you have to remove this part specifically, okay, and it is wrongly placed. So you'll have to destroy it all, and let's say there's a
लेजर केलिंग ने कुट्टे पण होऊ शकते मी जगात निवांत तरी जे 1 लाख रुपये पेमेंट आहे ते भरावं लागतं.
Can you repeat again? Okay, there must be a mistake. So let's say that you have to remove this brick, okay? So the other bricks have to be removed from it, so that you can take out this brick when it is it is placed there for 24 hours. Okay, it is so solid now, and some cost is there to remove it and then place it again. But with the additive manufacturing, you can remove this layer. It is what it does is 3D printing. If you have seen that, it does layer by layer printing. So this will, let's say I have to draw a circle. Okay, so what it will do is first it will draw one layer, then it will draw second layer above another, then other and other. So it will go like this, and that is how additive manufacturing takes place. Okay, so using this, we can there's some while building a house, some resources are being used without any reason. Okay, let's say that you have to build this house till this limit, and this is your extra cost that you are bearing. So why do you have to do it? You don't have to do it, and with this additive manufacturing, you can remove this dilemma. Okay. So 3D printing can help recover from natural disasters really fast. Okay, so you must have heard that in Uttarakhand and Himachal Pradesh last year, many houses were destroyed. Many, like you hear it every year. Okay, so due to natural disaster, many houses were lost, roads were lost, and this can be those houses can be rebuilt again within. If we are talking about this Episcore can build that house within 24 hours. So that recovering from natural disasters is really fast using 3D printing machine. Okay. Then comes a step ahead for the poor. Let's say there are so many poor that you see around us, around you every day. Okay, you go to some market. There's beggars. There's every kind of people. You find them there, but getting them a change for things. If we approach the government at the right cost and for the right things, they can. What government does is they are still making some arrangements for these poor. They are building some kind of houses so they can sleep every night. But let's say that giving them a house, giving them a roof, we can build them this house at a very low cost, and the government will be really happy to help these poor with these kind of 3D printing things. Okay. So how the traditional machinery was used. So this kind of a setup was there. Okay. So this was a 3D printing machine which used to move in the environment, like to and fro movement was there, and it can move from the left to right. So different kind of, let's say that we have drawn some kind of drawing in the Autodesk, and we want to print it. So it was loaded in this machine, and then 3D printing was done according to that. Okay, but let's say that you have to do this on site. You are in Bangalore now. You have to come to Pune, and you have to build that house there. So getting the traveling cost that you will bear, the cost of reassembling it, the cost of so many people to travel, you have to let them gain knowledge for it. This was really high. Then this the thing that I was talking about, that it was not printed on site, it was printed in a machinery, it was printed in a workshop, and then it was moved to the place. It beared a very high cost. Okay. So the traditional machinery didn't even lift the research facility, and some kind of innovations was still going on, but it couldn't be done on a large scale. Okay. Then the machines were really bulky, and it was the cost then increased because of the bulky size. Then they had height restriction that it could have been built to some specific height. Let's say that you have to build a skyscraper. It couldn't have been done using these kind of machine. Then they were difficult to transport, and then they were difficult to reassemble it again on the site. And printed walls assembling is done on site using these kind of things and these kinds of machine, and that is why it was not used. What all? Okay, so coming to you, what all do you think that would be more disadvantage for these kind of using these kind of machine?
Mostly, sir, we can say the unemployment will also increase.
Yeah, no, I mean that is like, but the cost of bearing taking that machine from one place to another will be also. Let's say that there's a company, XYZ company. Okay, so they have a 3D printed robot. So taking that robot from one place to another, that will cost them a good amount of bucks, right? So even if we give people employment, but how will they be able to pay their salary if they are not making good profits, right?
High skilled workers are required.
Sorry?
High skilled workers are required.
Yeah, absolutely. You require highly skilled worker. You cannot ask a labor to do this job, because it will require very precision work of you will require mechanical engineering, and then you'll have to have had work on these kind of 3D printing machines. And then you should also know the if let's say that this structure is not according to the requirement of the consumer, you will have to build it again. So that kind of skills are required. What more do you think would be disadvantage for these? Okay, so these are some of the disadvantages that we are discussed. So getting on how these disadvantages were overcome. Okay, so Episcore, this company, they introduced the world's first 3D printing robot. So this robot could maneuver 360 degree. It can let's say that it has to build this concrete here. Then it can go to the backside, left, right, up and down, anywhere. Okay, so it was really compact. This size of 8 feet 8.5 meters. This can be reduced to just 4 meters. Okay, then this 3.1 meter could be reduced to 1.5 meters. So it could have been compact like this and also like this. Okay, it weighted around 2 tons, and the maximum operation zone was 132 meters square, and printing output area per day was 100 meters square. Okay, so this 3D printing robot couldn't have worked alone. Okay, so because it will require some kind of mixing and pump system. Okay, so with which it can mix the ingredient that was used to manufacture some kind of house, and then pump system was also used. So initially this company in 2017, when they started building a house, they had this silo and then this pump system. But eventually, we'll be studying in the coming slides that how they reduced it and how they have an automated pump system now. Okay. So commissioning on site takes not more than an hour. So let's say that we were talking about the traditional methods. Okay. So how much time do you think that this machine required to set up? Just give a rough idea. How much time do you think?
It may be half an hour and
no. This machine
5 to 8 hours.
This machine almost took 3 to 4 days to reassemble it again. Okay, comparing to this machine, which only takes just an hour. Imagine that the advancement that was done using this robot. right? That was really commendable. Okay. So we, using this robot, we saved time, we saved money. Now that the task that was done in 10 days, let's say that is reduced to 7 days, and less human intervention is there. You don't require that much of a skill as using the traditional robots. And those were the things that were, and this can be commissioned on site. And this you don't have to print some kind of object somewhere and take it somewhere. You can just take the machine and ask that machine to do anything and print anything at the moment, right? This machine can operate at low temperature as minus 35 degrees Celsius. And so that there are houses in Russia, there are houses in Ukraine, then there are high altitude houses. You can take these machines there. You can let's say that our soldiers are sitting in Leh Ladakh at minus 35 degrees Celsius, minus 40 degrees Celsius. So this machine can be commenced there, can be taken there, and those houses can be built without if we use a traditional method of building, we'll be getting some bricks from somewhere, cement from somewhere. It will take many days. But using this robot, this can be done within few days, right? So that is the advantages of this commissioning this robot, right? So what are the components that this robot was named as the Frank, the 3D printing robot? And let's see what are the components that were used in these robots. So this is the whole robot, and this is the pump and silo, which you saw that how it was, that it was so different. You had two different things. Now it is just single machine, which can be moved anywhere, and this is the whole robot. Okay, that is commenced, that is commissioned in different places, so that different kind of task is performed. So this is the point which can be moved to and fro, and the length that I was talking about, it can reach up to 14 feet and 5 inches, and with height it can reach up to 10 feet 5 inches. Okay, so that is the amount of application where it can move. Any questions so far?
Regarding this, regarding what is the durability of structure?
The durability, the durability depends on the kind of thing that we are using, the kind of mixture that we are using. But the geopolymer concrete that I'm talking about, the durability of that compound is at least 57 to 70 years, right?
We are using ingredient like concrete paste or other thing like iron rod or other thing in this.
See, it is the geopolymer concrete that you will also study, and you can also study after this lecture. So geopolymer concrete mixes of fly ash. Fly ash is being also used in the bricks nowadays. Okay, so fly ash is cheap and it is very durable, and it is really hard to break it. And fly ash and mixture of iron.
Sir, your voice is not clear, sir.
Is it clear now?
Hello.
Is it clear now?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So the thing that I was talking about is geopolymer concrete.
What type of assays you are talking about? What type of assays?
I'm talking about. Can you repeat, please?
What type of geopolymer?
He want to ask that
I'm asking that
what type of ash is fly ash?
Geopolymer.
Okay, so geopolymer that I'm telling you that. So geopolymer concrete that we are using, it is a mixture of fly ash and the left out compounds of iron productions. Okay, so there are many chips that comes out of the manufacturing industries, and that is iron chips. So that is mixed with the fly ash, and that is used in the geopolymer concrete that we are using. Okay, I may not be a good expert on the geopolymer concrete, but what I'm talking about here is the advancement in the robotics that is done, right? So the geopolymer concrete that we are using, it can last up to 57 to 70 years. So fly ash is also, used in the traditional brick making that nowadays is happening because it is cheap, it is very durable, and the structure gets very strong. But exploring more field, we got this geopolymer concrete that we are using for these kind of 3D printing robots. Okay, I hope that clears my question. Okay, so is there any other question?
Yes, sir.
Please ask if there's any other question, please. Okay, so moving further, so let's say that this, coming back to this thing. So how this is done? Okay, so initially what was tested is they had to 3D printing robot. So they require some kind of speed, some kind of pumping system that to produce. Let's say that this is the concrete that is laid. It is 5 centimeter in width, and it had to go. It had to be done around. So let's say this is just 5 centimeter. Okay. So you had to commission some kind of speed and some kind of the pumping so that 5 centimeter can be achieved, and that is that is differentiated on different kind of structure. So let's say I have to build a skyscraper. So maybe I'll be taking this width as 10 centimeter. So this robot will be moving slow. Okay, so that it spreads, the concrete spreads. So if I have to build I don't have to build a skyscraper, I have to build a house. So we can use 5 centimeter. I'm just giving an example. This may not be just 5 centimeter, it may be more, but that is just to give you an idea as to how this robot works. Okay. So first was this robot and the pumping system that was used, and this can be moved to and fro so that it can reach to some places. Okay. Then comes the height that we talked about. It is 10 feet 5 inches. Okay, 5 inches, and then the reach is 14 feet 5 inches. Okay. This is the tip. This is the gun that we say, and they have some kind of actuators, and that it decides as to at what pressure the concrete has to be spread out, and at what speed the commission is going to take place, and some kind of so this robot also has a robot controller, so which is programmed with the help of computer, and so that this additive manufacturing can be done. So let's say this is a big house. Now these are 4 different rooms. So this robot is here, okay, and its maximum reach is there, and so it built these walls. So now what can be done is when we have to, so what we will do is we will install those drawings from the Autodesk one by one. So first we'll install the drawing of this room, then we'll install the drawing of this room, placing this robot here, then this. That is how this manufacturing is done for the buildings. Okay. And these are the actuators that I'm talking about, and that is how this concrete is laid. And let's say this is a wall. This is going to be the original wall that is going to be placed, and this is going to take a maneuver loop. So make this structure stronger, and to make this structure last more. Okay, so it can be more durable, right? Then these are the wheels that is equipped on the controller and the pumping system that we are talking about. So this is where the
Oomang,
yes,
you have to remove your written lines and all. Pictures are not seen clearly. All your written lines in red color are more visible.
yeah, please, sorry. Yeah, I'm really sorry for that. Okay, is it clear now, right?
Please
Okay, so
continue.
this is yeah, please. So the thing is, these are the wheels that is commissioned on these controllers and the pumping system that we are talking about, so that it can be moved from one place to another without the human intervention, and some kind of sensors and with the inclusion of the IMP and AIML, this robot can maneuver with the robot. This controller can maneuver with the robot, and so that it doesn't have to be controlled by a human. Okay. This is the auto cleaning system that this robot has. So this is a ball that you can see right here, and this ball, what it does is this say that the concrete, it is hard on the tip now, so the concrete cannot just pass through. Okay, can you please mute yourself? Okay. So what this ball does is this ball travels through the whole line system of the concrete that is being that is being spread out, and it cleans it up if there's a concrete that becomes solid on the tip of the this robot. Okay. So it has this auto cleaning system which is equipped in it, right? So this was the first house that was built by Episcor in 2017. It was built in Russia, and the temperature that was there was -35 degrees Celsius. And this was the inside of the room, which was done afterwards. And using this robot, there's one also advantage for this. So let's say that you build a house using cement and bricks and everything. Okay, you need to give it some time so that it solidifies, and so that you can do other work like painting it or maybe doing other stuff, right? So that is not the problem with this robot. Okay, so with the robot, when the welding is done, it just takes around 5 minutes to solidify, and other printing can be then the painting can be done. Okay, and for all the floors and flooring and all these things can be done, right? So the house that we are talking about is 38 meters square, and in talking about in Indian terms, it was around 45 gaj that we talk, and it took almost 7,87,000 to build this house, which is equivalent to $10,000. Okay, so that was the amount of that was taken to build this house, and the cost of this house included all the all the equipments from ranging from roof, from foundation, from installing all the windows. So these were everything was included in it. So if we talk about the same house to build in India, it costs us about 12 lakh, and that is like 5 lakh saved for it, which can be invested, which we can invest on different things, right? Okay, just hold on, please. Right. So this robot also set a Guinness World Record of building a house in 17 days. This was a multi-storied house in Dubai. This structure was 9.5 meters tall, and the whole area of the structure was 10,000 square feet. Right. So that was achieved by the Episcor. Initially, when this company, so I'll tell you the story. So initially, when this company approached the Dubai government that they want to build this house for them, so it was considered as a joke, as that no house can be built using this, and within 17 days it cannot be done, and they took it as a challenge. And the engineers who was collaborating with this company, they also took it as a kind of a prank that they were expecting it to be. And then initially, when the company started working, it was a shocking moment for whole Dubai government, and this company then set a Guinness World Record for that. Okay. So as we talked about that, it took 17 days for this company to build it. Okay. So the misconceptions regarding these kinds of robot, and so there are some misconceptions that this robot is going to take away all the jobs. It will still require some kind of jobs for, let's say that even if we build this house, okay, so the installing of doors, installing of windows, installing of roof, installing of the basic foundation, these were all done by human, and we require some kind of human labor in everywhere. And there's 3 laws of robotics that so the first law states that a robot has to always obey a person. Okay, always obey a human. So it can so robot where there is a robot, it will always obey a human, and human intervention will always be there, right? Even I'll tell you about the future plans of the Dubai government that they were planning. So they have discussed and decided that 25% of all the building that are going to be built, they have to be 25% of the component of the building has to be made by a 3D printer. So that is what the future of 3D printing is taking place. So as we talked about that many tasks will require manual labors. So like loading this robot on this machine, it will, although this machine has automated driving system, it will still require a human intervention so that automation can be done. Automation is being done correctly. Okay. So let's review that what we have studied in these slides. So we talked about the traditional 3D printing machine, the disadvantages of it. Then we discussed a few other disadvantages using that machine. Then we discussed about the world's first 3D printing robot and how it was commissioned and how it came into being. We studied the advantages of using that 3D printing that, after the natural disasters, we can build it again very quickly. And, we can use this to build houses for the poor. And we understood the concept of components used in the 3D printing robots and how these can be commissioned in the current environment. So coming to the end of the slide, thank you. And if there are any questions, please let me know.
I am Jayanna from Bangalore.
Yes,
Is the Indian government also somewhere? We saw that some of these buildings in the remote areas and all.
Sir, actually, I'll tell you about this. So the thing is that Indian governments, let's say for just yesterday, the PM Modi was encouraging the building of these drones, right? So that is how it is some unexplored field, and the Indian government is taking initiatives to collaborate with the startups that are coming into being, and they are raising many fundings for this. Even let's say about the ISRO. So ISRO after 2017, it has collaborated with at least 50 companies, 50 startups to make this 3D printing objects so that can be commissioned into their spaceship and which will take place for the space exploration. So many companies are still there, but this field, as I say, that it is still unexplored and people are still exploring it, right?
Hello, I'm Manish from Gurgaon. I just want to inquire, who can be your corporate customers in India for this kind of technology?
Sorry, can you repeat, please?
Who can be your corporate target customers? Any category like EPC, large infrastructure companies who can utilize their 3D technology?
Okay, so the thing is that people don't feel this kind of technology is reliable. As we heard a news few years back, 1 or 2 years back, there was this world's first 3D printed bridge. So there was some limitation to it, and it collapsed because of it was not it had a limit of 10 to 15 people, but there were 20 to 30 people on that bridge. and it collapsed due to that. So people still feel that it is not reliable, and this thing is still being explored so that the commission can take place at a very collaborating thing, and so that these 3D printing technology can be commissioned in the coming future.
Is Larsen and Toubro is entering into this technology?
Is, sorry sir, can you repeat?
Larsen and Toubro.
Yes sir. Okay,
L&T is entering in.
So there are still some companies that these companies are not taking much initiative as the startups are taking, but there are many startups. I don't remember the correct name for them, but these startups are still working it out so that this can be used on a large production. So Episcore, as we talk about, they are in Florida currently, and they are getting very many contracts for building these houses or buildings. But companies still have to explore these fields so that this it doesn't, as we get in the comment section, that earthquake can be there, and these kind of situations can be there. So what will happen? So it is still a house, it is still bricks and rocks, and it might get affected due to these kind of calamities, but it is still being explored.
Actually, up till now, I have heard of this technology being used in manufacturing industry in India, like spares, power generation, other. But it was really informative session to hear it from you being used in construction industry. So let's deep dive more into it, how it can benefit the Indian civil engineering construction industry.
Yeah, actually, see, the thing is that I'm a robotics engineer. Okay, so we are collaborating with different kind of. So this is a collaborating thing. Okay, so let's say that robotics is a collaboration of mechatronic, mechanical, electrical, computers, and these kind of various fields. So that is how this 3D printing is, a collaborative field also, and different people come together to build these kind of things. So I can improve the robotics, and one civil engineer can do improve the manufacturing part. So what kind of concrete and mixture has to be there, and then there's some other people who can look at different aspects. So collaborating environment has to be there to initiate these kind of things, right? Okay, so I have some questions in the comment section. So we'll do this. Okay, so the size and required. Right. Okay, so I only have one question. So what is the response of this building during earthquake or wind? Is it similar to the conventional one? So see, the thing that I told you, that this concrete mixture, they have they have a mixture of fly ash or these things that I was talking about, the iron chips. Okay, so this also improves the durability of the house. But if earthquake is like on a 7-8 scale magnitude, so I mean it will still suffer some damage. But it will still this manufacturing will still have a better will not have that bad of an impact like on the traditional house that is built. Okay. So what is the cost of robot? So the cost of robot can be from somewhere between 5 lakhs to 25 lakhs that we get right now. But this robot, it is of 15 lakhs if we talk about in the Indian terms. And if we remove some automation part, the cost can be reduced up to 8 lakhs. So what this company does is it does not sell robot. This robot is this company rents it out. And let's say that I am a manufacturer and I want to get this robot. So they will rent it to me for on some day basis or for some month basis. And I can commission that robot any way I want to. And that is how this company is working. But different things can be done. And yeah, I mean, that is how it happens.
Hello, sir.
Yes, please.
Yes, sir. I'm Amit from Gujarat. Sir, my
Okay.
question is, what type of work does a mechanical engineer doing in this field? Means,
What kind of?
what types of work does a mechanical engineering doing in this field? Means, manufacture this machine or maintenance or something else, designing.
See, I'll tell you about my experience. So the thing is that I was working in JBM company and I was the robotics engineer there. So I was the only robotics engineer in that whole company. So other than that, I had mechanical engineers around me, I had electrical engineers around me, I had computers engineers around me. So what they all used to do was, so electrical engineer was, there to for the wiring of the PLC panel box. You know PLC, what PLC is, right? So the PLC, with PLC, with the help of logic controllers, so you can, it can be used in the place of relays where there are many relays used. You can use in place of that. And so what electrical engineer was responsible for that thing, for the wiring of that system. Mechanical system was there for the maintenance of the system and overall running of the line. Okay, so mechanical engineer was responsible for maintaining the robot, for weekly maintenance of the robot. If there's any program that fails, he has to install the program again. Then there was computer engineer. So engineer was used. Computer engineer used to draw the whole programming aspect of the robot. So from installing the program to commissioning it, and then running and testing it. So that is how different field collaborates in these kind of things, and some kind of application is carried out.
Sir, what about the electronics engineer?
See, electronics engineer also learns about the microcontrollers and the microprocessors, right? So microcontrollers and microprocessors were commissioned on the line, and different stampings and different identification of the parts of the PC that were made and came out of the field. They were electronics engineer used to take a look at that and maintain that particular machine. Then they also used to these engineers also used to collaborate and do different things, like mechanical engineer was also doing electrical thing, and electronic engineer was also doing computer thing. So when you go into the company, you go into the industry. So these all things you learn from time to time. So we hear a saying from our elders, कि time सब कुछ सिखा देगा, right? So time, when you give time to something, you will learn everything. Okay, so that is how it was done. Are there any more questions? Okay, so if there's no more question, I'll share you a feedback form. You can share how you like the bootcamp, or what improvements can be done. And we'll be taking more of these kinds of robotic sessions in the coming week. And let's say we were talking about the manufacturing industry or the building industry in this lecture. We'll be talking about various applications that robot is where robot is being used and is being commissioned, right? So this is the feedback form, and I hope you all have a very good evening, and I hope you all learned various good things from this session, and happy weekend, everyone. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Yes, Jaina sir, I can see that you have raised your hand. Is there any question?
Continue such type of innovation lectures, so that at least somewhere people will get to know. And as you are telling, interdisciplinary activities are very, very important for new innovations and technologies.
Yes, actually, so the thing for this kind of session is that introduce to the students that how these fields are expanding, and what all do we have to learn. And there's a misconception in the mind of the student that if there are if they are mechanical students, they cannot go into different fields, or they are electrical engineers, they cannot go into different fields. But these fields can be explored. We are engineers, we build things, right? So these things can be learned very easily, and having that mind of an engineer, we can achieve different things like this Episco startup. These this I'll tell you about this CEO of this company. This company, the CEO of the company doesn't have a BTech degree, okay, but still they are running a or a civil, degree, and they are running this building industry, and they are innovating it very good. So that is how we can do things, and we can get some really good aspect, and we just have to observe these small little things that we see in day every that we see in life every day, okay. And innovation can be done. We can just think of an idea, some crazy idea that people will say ki it cannot be done, but these things can be done if we just explore it a little bit, right? So that is my opinion on this.
Yeah, we have to continue such seminars and all, such webinars. Then only people will try to understand.
Yes, sir. Actually, we are collaborating with different colleges every week or every month for conducting these kind of sessions. So I had a colleague; he had different session for EVs and different things, and I'm taking the robotics session. So
Why don't you also collaborate with some of the universities, colleges? They will be guided by the universities with their curriculum, with their syllabus.
yeah, actually, sir. With the filling of this feedback form, you'll get a link for our company, and some marketing person will reach out to you. So he'll tell you about the courses that we are developing for the robotics and for different fields and different multidisciplinary field. You can just enroll into that, and you'll be gaining a huge amount of stuff. But also, sir, with the colleges, we are collaborating for the in-house practical things. So so that they can get practical exposure as to what is happening in the industry. So
I am in contact with Abhishek of Bangalore office. Let us see how we can take together to bring such type of knowledge sharing program right in the universities. Otherwise, students, you are taking so much pain. Number of students attending is only less than 100. This is what sometimes we also feel your efforts are huge, but the responses are not very much. Oomang, I congratulate you. We'll take up, we'll try to support. I am a retired person. Many of your webinars, I am quite impressive.
Right.
And I am in contact with your Bangalore office also, Abhishek, and also your particularly Sheikh speaks very good on automobile, because I am an automobile engineer.
Yes, sir. Our boss, Sheikh, Mr. Boss Sheikh.
Thank you, Oomang. Nice overview.
Right.
Please let us continue. Please continue.
So the thing, sir, that I was saying is that there's this thing that you were saying that my efforts are being wasted. But we had 50 students today. So even if these 50 students get an idea to do something different, we'll help them do different things. If they fill this feedback form, and if they have an idea, they can just let me know. I just go through this feedback form after my every session, and I can improve and help them by how they can do this and how they can initiate something that they have an idea of. Because students don't have an idea as to how to initiate. They get an idea every day, but they don't know how to initiate this thing, right? So we can help them do this thing, and that is why this feedback form is all about.
The feedback form you have to send by WhatsApp also. Sometime the moment we get out of this meeting, that link will not be there. We can't fill up it. Send it by WhatsApp also.
Yes, sir. I'll communicate this to my marketing team, and they will do this also, right?
These are very important because immediately, see, I am sitting in a park now. I may not be able to see many things now.
Right,
At
right.
least if I have in WhatsApp, I can think of, give some positive thing. Anyway, I congratulate ETC team. Excellent work is being done.
Yes, sir. Thank you so much. And I'll just convey this message to my team, and they will get back to you on this. And you'll get this form in WhatsApp also, right?
Yes.
Okay, sir.
Congratulations, Oomang. Thank you very much.
Thank you. Are there any more
Bye
questions?
bye.
Are there many more questions? Please let me know. Okay, so let's end it now. And thank you again. And just keep learning and keep exploring. Thank you.
Thank you, sir.